Here are your bell ringers for the day, so please pause the video and take a few seconds to work through these bell ringers. Alright, on the first one, when we're dividing a monomial, okay, we think about dividing it into that one first. So 36 divided by 6, that gives you 6. Alright, and then m to the fourth over m squared, that's m squared. Y to the fourth over y, that's y to the first power, so that'd be y cubed. So that's my first term. And now we go the other one. All right, so minus 18 divided by 3 is, or 18 divided by 6 is 3. M cubed over m squared is just an m. And y squared over y, that just gives you a y. So that's your polynomial after you're done with your division. Okay? Second one, simplify with long division. So we're going to set that up with the division brackets there. So over here, I'll just kind of work it over there. We've got m cubed minus 3m squared and minus 18m plus 40. And we're dividing by m plus 4. So then you got to ask yourself, what do I need to multiply by m to get me to m to the third power? All right, that would be an m squared. Okay, so we're going to take it times m squared. Now you got to take it back and take that m squared and FOIL it through there. Okay, once you FOIL it through there, that tells you what to write below that first line. Alright, so if I FOIL that in there, I'm going to have m cubed plus 4m squared. And since we're writing it down there, we subtract. So change the signs. So those are gone. And now we have negative 7m squared. And now we bring down that next term, negative 18m. So now what times the m out front will get me to that negative 7m squared? Well, that would be a negative 7m. So I multiply it through, FOIL it through there, gives me negative 7m squared minus 28m. Okay, since we're putting it down there, we subtract, so you change your signs. So the 7's cancel, and we have negative 18 plus 28, that gives you a 10m, and we bring that 40 down. Okay, now what times m will get you to 10m? Well, that's just the 10. Okay, plus 10, FOIL it through, or distribute it through, 10m plus 40, and then change your signs, serve subtraction, and we get everything to cancel out, so there is no remainder. Okay, so that's your answer. Remember, if you were to get a remainder, that it would be whatever you have down here, whatever you have down there on the bottom, it'd be that divided by your binomial that you're dividing with. Okay? Next one down here is synthetic division. Okay, so if you didn't remember how to start that one, this should help you. Okay, that's the one with the box. And then you think about this one, you set it equal to 0, and you solve for p, so p equals 2. That's what goes up here in the top left-hand corner. And now you have to remember with this polynomial, since there's only 2 terms, it's a binomial, but your power is 3, so we have to fill in all those missing pieces. So this would be my 1p to the third, 0p squared, 0p, and then negative 8. And remember, I like to make those little dashed lines down there. That's just going to show me that my remainder is whatever I have down there in the bottom. Okay, so first one comes straight down. That 1 comes down. Now we multiply the 2 times the 1. So that gives me a 2, and now we're just adding. So 2 multiplied by a 2 again. That's 4. So 4 down there multiplied by a 2 again, and that gets you to an 8. Negative 8 plus 8, that's 0. So we don't have a remainder on this one either, which is good. I guess it makes it a little easier. Okay? So now we have to change these back into polynomials. Alright, so if we have p to the third that we're starting with up there, okay, we're starting with p to the third and we're taking out a p. So your final answer is going to be something p squared. So that would mean I have a 1p squared plus 2p plus 4. So that's your final answer. And the same thing applies here. Remember, if you get your remainder right there, you can write your remainder over the top of your polynomial you're dividing with. Okay? So those are the bell ringers. So you guys can have a few minutes now to check homework questions with each other, all right? I'll be kind of lenient when I'm grading the homework problems because I'm not here to answer questions, but you guys need to work together at your table to figure out your homework answers for the homework, okay? So please pause the video for approximately 10 minutes, 5 to 10 minutes, and give the kids time to work through homework and ask questions of each other. Okay, back to starting the next section. So that's chapter 4.4, or chapter 4.4. It's graphing polynomial functions, all right? So now you guys have a exploration worksheet, which you're going to take 20 to 30 minutes. I think I have 35 or 30 to 45 minutes on here. It shouldn't take you that long to get through it. So you guys are going to work together on this worksheet at your tables, all right? You're going to work together on this worksheet, and you're going to kind of explore the different parts of polynomials. Make sure that you read directions on the worksheet because there's some directions that you need to make sure you follow carefully. If not, you might not know what's going on. All right, so please hand out the worksheet and pause the video again, and students will work through that. I would say we'll see where everyone is, 20 to 30 minutes mark. Okay, so everybody's done the 15 to 20 minute mark, then we can get started on the notes and the kids will have more homework time. Okay, so please pause the video. All right, at the end of that sheet there, you guys had information about polynomials, and you could have already filled in the blanks if you wanted to, because we've done this before in our notes, okay? So just thinking of the first one, a polynomial. Okay, a polynomial is a number of variable or a product of numbers of variable, okay? A blank is a monomial or sum of monomials, okay? That would be a term. Okay, a term is just a monomial. A single polynomial or a single piece of a polynomial is a term. Okay, second one, a polynomial function, or a polynomial function is a function of that form. Okay, and you guys have seen that before. I showed you this stuff in your notes already. The second term here would be plus, it'd be a to the n minus 1, x to the n minus 1, because remember, the only thing we care about is that exponent is going down by 1. So say we have a polynomial that starts as x to the 5th, okay? Say we have something at x to the 5th, so you know that the next term in line is going to be x to the 4th, all the way down until you get to a constant. Okay, that's just standard form of a polynomial, okay? Then a sub n cannot be 0, so the number out front cannot be 0, and all exponents are whole numbers. Okay, whole numbers, and this we've talked about this already before. And the coefficients are all real numbers. So you don't want to see any imaginary numbers in there. Okay, so make sure you guys fill in the blank section on that worksheet. Pause the video at any point in time if you need to, or ask the sub to pause the video if you need time to catch up. Okay. Second part of it, okay, the number out front, that'd be the leading coefficient. Leading coefficient is a sub n. Okay, and then we'll look at the other pieces. The constant in the back is a sub 0. Okay, the constant is a sub 0. Okay, remember that number in the back end, we could also say that's our y-intercept for a polynomial. Okay, that would be this one right there, that's your y-intercept. Okay. So then the rest of those, they just kind of fill into place. I don't remember what I have for this one, so we'll skip it for now. Second one, a polynomial is in, or not second one, the fourth one. Polynomial is in standard form. If the terms are written in descending order of exponents. Okay, so those are a few other things that are key for polynomials. All right, so make sure you fill in the blanks there. So the next thing you guys had on your worksheet was this, so that chart. That chart should be on your sheet that I gave you guys, all right? So we have common polynomial functions that we want to look at. So we're going to fill in the chart. So just make sure you're following along to fill in the chart here. So this first one here, is there a variable? Well, no, but could you add a variable with a certain power? Yeah, you wanted to if you had x to the 0, but that's not really going to tell us anything. Okay, so my degree here, if you think of that, x to the 0, that tells you your degree. So remember that up there is your degree. That exponent is your degree. So my degree here is a 0. And if it's just a number, all right, let's get rid of that x again, because we have just a number. What do we call that in math? Well, we call that a constant. Okay, so fill out your chart while we're going through this. Second one, we can fill out our degrees now, because we kind of have a review of what degree is. Okay, it's the power of x. It's the biggest one. So my degree here is a 1. My degree for the next one is a 2. Degree for the one after that is a 3. Okay, and you can fill out the rest of your chart. I'll do that as we're going down. So the first one, or second one here, that, if you remember what that equation looks like, it looks like y equals mx plus b. Which things are in the form of y equals mx plus b? Lines, it's linear. Okay, that's a linear polynomial. Then the next one in line with our degree of 2. Okay, our degree of 2 here, well, we just got done with these, a chapter full of these. These are called quadratics. Okay, they're up on the wall. Okay, we go further down. Third power, well, if you think about how we read something to the third power, you say it's a cube, or you cube, so this is a cubic. Okay, and fourth power, that would be a fourth degree, given by our fourth power, it's the biggest exponent there. 4, you might think quadratic again, but we already used that, so it's square. This is actually called a quartic. Okay, so you might think like quartile, that might come to mind, listed as a quartic. Okay, so those are the different polynomials, and you guys should have your chart filled out. Okay, now we're going to review a little bit. So think about if these are polynomial functions or not. So I'm going to show you the picture again, or show you the parts of the polynomial, and I want you guys to sit at your table and kind of share quietly what you think if they're a polynomial or not, all right? So the first one there, is it a polynomial or not? So we'll take about 15, 20 seconds, think about if it's a polynomial. Okay, we might cut it down 10 seconds. We should know this by now. Remember, if you're looking for something that's not a polynomial, you're looking for any variables in the bottom, or you're looking for any square roots of variables, or any negative exponents of variables. These are all three things that are not polynomials. Okay, so those are the dead giveaways that you know that they're not. So, first one, yes, it's a polynomial. What's the degree? 4. Okay? So the type, that's the new thing here. The type, well, if we look at our chart, 4th degree polynomial, that's a quartic. Okay? And then leading coefficient, that's a new thing that we just added here. Okay, the leading coefficient. This is the number in front of the variable with the largest exponent. Okay, that's your leading coefficient. That's the number in front of the variable with the largest exponent. So if we're looking here, variable with the largest exponent right there, what's the number in front? That would be a 1. Okay, so yes, degree 4, quartic, or the leading coefficient is 1. Second one here, is that a polynomial? Well, think about the things that I said are not polynomial. They kind of move them down. Okay, there and there. Does that fall under one of those categories? Yeah. or not, because there is no variable there, so that doesn't matter. Okay, we don't care about that. The only thing I'm looking for here is that right there. You might think that it's not because there's pi, but it is because pi is just a constant. So this is a polynomial, second degree, so it's a quadratic. Leading coefficient is pi. Okay, let's look at one more. So, last one. Is that a polynomial? Should be kind of a dead giveaway. This one is not. I look right there. I have a -1 exponent. Okay? That tells me it's not a polynomial. So, no. Alright? So, next one. I want you guys to make sure you write this down. You're going to have to know how to do this. Okay, so we're evaluating polynomials now. And it is in function notation. Okay, so we've done function notation before. We're not going to spend a whole lot of time reviewing it. But just remember what you do with the stuff inside the parentheses. Okay, so take a few seconds to write this down. Pause the video if you need to have kids write it down. Okay, when we're given something like this, so this whole thing right here, we're taking b of 2x minus 1, and we're subtracting 3 times b of x. So we're going to have to do two different kinds of functions here, or do two different kinds of function operation. The first one, we're plugging that 2x minus 1 in for m. Alright, so it's going to look like this. Alright, plugging that 2x minus 1 in for m. Now I have the second one. And there. So that's just the first one. I'm going to do these one at a time. Okay, so I'm doing this first one first. Alright, that'll be right here. That's going to be the blue. Alright, so I got to FOIL this one out here. I got to FOIL that. So if I FOIL that, I'm going to get 4x squared minus 4x plus 1. And then I have this written out, so I can just add those together, so it gives me 2x minus 2. Now I have to distribute. So it gives me 8x squared minus 8x plus 2 plus 2x minus 2. Combine like terms, we get 8x squared minus 6x, and then that gives me plus 0, so that cancels out. Now I'm going to do the second one here. -3 times b of x. So that means I'm plugging an x in where the m is, but I'm taking -3 times that. So it'd be -3 times this whole thing here. Oops, and I want x, not m. I want x squared plus x minus 1. Okay, so now it'd give me -6x squared minus 3x plus 3. Okay, now I'm going to put this together with that. And that'll be my final answer. Okay? So 8x squared minus 6x squared, that gives me 2x squared. -6x minus 3x, that's -9x. And then we just have that positive 3 hanging out in the back end there. So that is the answer. Okay? So I did these two individual pieces here. I did the blue first, which is that b of 2x minus 1, and then I did the green, which is that -3 times b of x. And I did that just to kind of organize it a little bit. That way you don't try to do it all at once. Kind of break it down in pieces. It makes it a little bit easier. Okay? So go ahead and try that one now. So please pause the video and have students try that one. And I will work through it after you press play. Alright, so on this next one. So we're going to do the two different pieces again. So we're going to try this one first. All right, and this is the function that I'm using. So b squared plus 3. I'm plugging that 2x plus 1. I'm plugging 2x plus 1 in for b. So it's going to be 2x plus 1 squared plus 3. So if I FOIL that out, I get 4x squared plus 4x plus 1, and I got the plus 3. So I got 4x squared plus 4x plus 4. All right, the other one I'm going to do in red. So it's negative 2, and I'm plugging x in for the b. Gives me this. Okay, and now I just combine them. So that will give us, for a final answer, we're going to have 2x squared, and then we don't have another x term, so it'll be plus 4x. And then 4 minus 6, so that's negative 2. That's your final answer. Okay, so they're not too bad, you just have to make sure you organize. Alright? So that would be using function notation with polynomials. Okay, when we graph polynomials, now this is where you guys are going to have to kind of think back to how we have n behaviors of functions, okay? So first we have odd and even functions, okay? So if we got something like these two, I'll have to scroll down a little bit. Okay? Right there, look at the end behavior on those two. Okay, if you're thinking about the shape here, these are parabolas. Okay? If the end behavior both goes in the same direction, then it's going to be an even function. Okay, we're just classifying functions as odds or evens. Okay? Another way I know that the function is even, if I'm not looking at the graph, I look at the exponent. Okay? X squared, what is the degree of that function? It's 2. Is 2 odd or even? 2 is going to be even. Okay? When they both go up, like this one, okay, both of those are going up. Both of our ends are going up. We know that it's going to be a positive number out front. So that's the leading coefficient. Leading coefficient is positive for this one. Okay, now looking at the one below here, both of these are going to negative infinity. Okay, that follows this over here. Okay, they're both going to negative infinity. Right here and right there. That's saying both of my values for the function are going to negative infinity. What do you think is special about the leading coefficient here? Since it's going down, that would mean that the leading coefficient is negative. Okay, negative leading coefficient. So those are two even functions. All right, if it's an even and the number out in front is positive, then both arrows are going to go up, both ends are going to go up. If it is even and the number out front is negative, then both arrows are going to go down. That's called an even function. Okay, so if we have evens, then we must have odds. So these are odd functions. Okay, these are both, one's a cubic and one to the 5th power. Okay, so again, let's look at end behaviors. So negative infinity down here, positive infinity down here, or up there, and switch it around. All right, the easiest thing I think of, okay, these are odd functions. The easiest thing you can think of here is a line. That would just be x to the 1st power, okay? A line would look something like this. If I had y equals x, okay, y equals x would just look like that. The end behaviors of y equals x are the same here because it's an odd function, okay? So if I have an odd function where I have negative infinity on the left and positive infinity on the right, your leading coefficient is positive. Now if I have a leading coefficient that's negative, then that means it's flip-flopped, okay? So leading coefficient is positive, it's going up to the right. Leading coefficient is negative, it's going down to the right, towards negative. Okay, those are a couple ways that you can remember if it's an odd or an odd function and what the leading coefficient is. Okay? Now, if you guys need a little bit extra help on this, you can rewind again and hear me explain some of these again, which you may need to. All right? But you can tell the degree of the function by the power, and you can tell if it's odd or even by the power, just because if it's 2, it's even, it's 3, it's odd. Okay? Then if the number out front on an odd is positive, then it will be like this one here. If a number on the front or in the front is negative and it's odd, then it will be like this one here. Okay? And that's the same with the squares or the even functions. All right? So we're going to get to graphing one of these here in a minute. So this diagram is also in your book if you want to look at it, and they explain it in your book as well. Okay? Then another thing we're talking about are zeros. Okay? Odd degree functions will have an odd number of real zeros. Even degree functions will always have an even number of real zeros. Okay, that goes with the degree of the function. Okay? So if I had x squared, that's an even function. It's going to have at least 2 zeros. Okay, it's going to have 2 zeros. If I have x to the 5th, or it's going to have at most 2 zeros, excuse me. If I have x to the 5th, I'm going to have at most 5 zeros. All right, that just goes with the degree of the function. Okay, so for this example, for the graph, describe the end behavior. All right, easy enough. Negative infinity there, negative infinity there, so we just have to remember how to write that. So as x goes to negative infinity, f of x goes to negative infinity, x goes to positive infinity, f of x goes to goes to negative infinity, because they're both going down. So second part, determine whether it represents an odd degree or an even degree function, and then state the number of real zeros. So, thinking back to that chart, you got to look at the end behaviors. All right? So, they're both going in the same direction. So, it's the one thing you might think of as a parabola. It looks just like a parabola. Okay? So, are parabolas odd degree or even degree? Well, since they're both going the same direction, it's an even degree function. And then real zeros, we can just get that from looking at the graph. So does it ever touch the x-axis? No. So there are 0 real zeros. Okay, and then let's look at this next one quick. Right there. These are the ones that are a little bit harder. Okay, so look at it for a little bit, and then see if you can figure it out. So first of all, to describe end behavior. So on the left, negative infinity. On the right, positive infinity. So that means as x goes to negative infinity, f of x goes to negative infinity. And then x goes to positive infinity, f of x goes to positive infinity. Now determine whether it represents odd degree or even degree. So if the ends are going in opposite directions like this, if we think back to that chart, that's an odd degree. All right? State the number of real zeros. So how many times does it cross the x-axis? Just once. So there's only one real zero. Okay? So last thing we're going to do here, we're going to try to graph one of these by making a table of values. All right? And I'll go back. If you guys need to have this shown again, then you can rewind the video. Okay? So here we're going to graph by making a table of values. So some of you guys have graphing calculators. Yes, you can do that, but I still want to see you do the work to plug in an XY chart. All right? So with something like this, we have to do more than just our generic 5 points. So I'm going to start at -3, and then we'll fill out a chart from there, okay? So remember, when we're making an XY chart, we plug all the numbers in for the X's. So I want you guys to try to graph this on your own without me doing it. So please pause the video and have the students work through the graph. Okay, back to this. The one tricky thing here is that negative out front, and I think that caused people some problems on the last test. All right, so make sure you pay attention to that when you plug stuff in. So plugging in the first number, my -3, it's going to look like this. And you can enter that just like that in your calculator, and it'll get you the right answer. Okay, but you have to use the parentheses. Okay, so -3 cubed, that's going to give me 27. It'll give me a -27. But I have that negative out front, so it's a double negative. Okay, -3 squared for the second one there, that gives me a 9. -4 times 9, that's -36. And then we have that +5 on the back end. So it's 27 minus 36. That'd give you a -9. Okay, so 27 minus 36, that would give you a -9 plus 5, that's -4. So I'm going to go through these, plugging in the numbers. So that gives me -8, so that gives me a +8 because that negative out front. This would give me +4 times the -4, so it's -16. So 8 minus 16, that's -8 plus 5, that gives you a -3. Plug in the -1 next. So -1, +1, +1, -4. So we have 1 minus 4, that's -3 plus 5, now we're at a 2. Plugging in a 0, that should be pretty easy, because if you plug in a 0 there and 0 there, they both go away, so it's a 5. Plugging in a 1. Okay, 1 cubed, so this is -1 minus 4 plus 5. So that gives you a 0. Plug in a 2. So -2 cubed. Almost there. So that's -8 out front. And then that's 4, it's -16. So we're at -24 plus 5, so it's -19. So we're starting to get some big numbers here. So let's just plug in a 3 here to finish it off. Okay, so that's 3 cubed, that's -27. 3 times 9, or 3 times 3, that's 9 there, times the -4, that's -36, plus 5. So we'd have 58, -58. So obviously you're not going to have to graph that one, but we'll graph the points that we have so far. So -3, -4. Smartboard's off a little bit. -2, -3. -1, 2. 0, 5. 1, 0. 2, -19. So we're all the way down here-ish. Okay, so I would draw a smooth curve connecting those dots. Okay, we're going up there, then this goes back down there. All the way down to -19, so we're kind of down there a little bit. Let me redo that one. That's going straight down. Alright, so we don't really have a good enough graph yet. So if I didn't have a good enough graph like this, then I would have to do more points over here in the negative area. Alright? But to save some time, we got to think about end behavior. Okay? So cube, that means it's an odd. So if we have this end down here going to -infinity, we know that odds are opposite, so I know that this one is going to kind of take a turn and go back up like that to positive infinity. And you would see that by plugging in more points, okay? So you'd have to plug in a few more points to get the correct graph. All right, but that's how graphing polynomials work. So let's skip the next example, and there's your assignment. Okay, there's quite a bit of graphing, so you're going to have to get yourself, I guess there's not quite a bit, there's a few graphs on there. So you have to get yourself some graph paper, which is up in the tray in the front. And do your graphs on graph paper, please. It will help you graph them better. Okay, if you got questions, let me know. I should be able to send some emails.